For today, our topic is all about data management. So the first topic for the data management under the MMW, or the mathematics in the modern world, is what we call data gathering and organizing data. Number two is representing data using graphs and charts. And number three is interpreting organized data. Okay, now let's continue. So that is our topic for today. Okay, but first and foremost, what is the definition of statistics? Okay, so statistics is a branch of mathematics that deals with a number obtained from a select or obtained from a set of data that may be used to represent data. Okay, so some of the statisticians, they use data to forecast, they use data to predict something that will happen tomorrow, the next day, or the next year. They can forecast, example, the number of COVID cases, okay? Number of COVID cases tomorrow or on the next week, next day, or next month, or even next year, okay? They can also predict where or when is this COVID pandemic 2019 will be ending soon. Okay, so that is the help of statistics. Now, based on this one, we're going to have a sampling in which that is what we call from a total population. Okay, but so if we're doing a research, definitely you have respondents, and if your respondents is too large or too broad, meaning you're going to have a hard time getting all of those respondents. So therefore, sampling technique is one of the best considered issue about this finding the different kinds of respondents that you have. Okay, so but for the meantime, what is sampling? Okay, so let's just first define what is sampling is. So sampling is the process of obtaining samples used in statistical analysis in which a predetermined number of observations are taken from a larger population. Okay, so that is a sampling. So definitely, if we're dealing on sampling, it is a part of the population in which part of the population is that is what we call sampling. Okay. Now, definitely, if we're dealing on sampling, we are reducing our number of respondents from the larger population that we have. Okay, example, if your study is all about finding the number of COVID cases in the Philippines, now, are you going to go in every municipality or in every barangay just to get the number of cases? No, we're just going to what? We're just going to make a sampling design in which this would be representation of this larger population. Okay, so that is sampling. Now, we're going to discuss the different kinds of sampling technique. Yes, definitely. We have different sampling techniques. Number one is what we call random or probability sampling. Now, sir, what is this random or probability sampling? It is a method by which every element of a population has an equal chances of being included in the sample. Okay, so meaning, if we're dealing on probability sampling, now, definitely, that every element or every respondent in your larger population can have this equal chance of being included in your study. That is what we call random or probability sampling. Okay, so continuing on this scenario, so if we're dealing on random probability sampling, we have four different kinds. Okay, we have four different kinds of techniques on how to select your samples based on random probability sampling. Okay, so what are those four types of random probability sampling? Number one is what we call the simple random sampling. Okay, kindly take down notes, please. Number one technique is simple random sampling. Number two is what we call systematic random sampling. Number three is what we call stratified random sampling. And number four is what we call cluster random sampling. Now, based on this one, what is the difference between those four kinds of techniques in selecting your sample from your larger population? Okay, so if we're dealing on random sampling, meaning if we're dealing on simple random sampling, we're just going to put all of those names of your population in a bowl, and then we're going to choose or we're going to pick. So meaning they have this equal chance of getting or being included into our discussion or into our experiment or into our research. Okay, but if we're dealing on systematic random sampling, we're going to have this what we call k plus 1 formula, in which, example, if your study is how many, what is the behavior of the mathematics, what is the behavior of students of PSAU towards mathematics. So that is your study. So if we're dealing on systematic random sampling, your goal, in order to get your respondent, okay, on this kind of research, meaning you're going to what? You're going to place yourself into the gate 1 or gate 2 of PSAU university, and then you're going to select your respondents there. Meaning, example, if your number is 1 to 10, so meaning I'm going to choose the first, or I'm going to choose the 10th student that will pass by to the gate 1 or gate 2 of the university. Then after which is the number 20, number 30, number 40, and number 50. So after the number 50 students, you just have these 5 respondents. So that is what we call systematic random sampling. Okay, now if we're dealing on stratified random sampling, I have here an example of stratified random sampling. Okay, so a stratified random sampling, it is divided into different strata or into different year level. So same as true with this example, if I have here first year students, the number of total first year students is equal to 2,400. The number of second year students is equal to 1,500. The third year students is also 1,500, and the fourth year students is equal to 600. Now, how will I'm going to choose my sample size on this stratified technique? Okay, so this is the scenario. Mrs. Buson was requested by the school administrator to conduct a survey about students' agreement or disagreement about the proposed reduced days of classes. She obtained the total number of students through the school registrar as shown below, like this. Okay, now, based on this one, we're going to have a stratified random sampling technique to choose how many samples are there or how many samples will Mrs. Buson get from our larger population. So for the first year, we're going to total all of this number of students. So that is equal to 6,000. So it is divided into 3 strata: the first year, second year, third year, and fourth year strata. Okay. Now, based on the first year, it is 2,400. Now, if we're going to get the percentage of this 2,400 into the total number of students, you're just going to what? You're just going to divide this 2,400 divided by the total number of students, which is 0.4, or simply that is 40% of the total population. Okay, so meaning based on this 2,400 students, I'm going to what? I'm going to get the 40% of 2,400. So meaning I'm just going to multiply 2,400 and 0.40, and that is 9,600. Okay, so based on the second year strata, that is 1,500. And then after which is wait. Okay, so 1,500 divided by 6,000, that is 0.25. So therefore, that is just 25%. So it meaning this 0.25 multiplied by 1,500, and that is equal to 375. Same as true with third year strata. Now, based on this one, let's proceed on the fourth year strata. So 600 divided by 6,000 is equal to 0.10, and then multiply it by what? Multiply it by 600. So therefore, that is just 60 students. So if I'm going to add all of this total number of students from our larger population, which is that is 6,000, it is equal to 1,770. So meaning Mrs. Buson will get this 1,770 students as the sample size of her study. Okay, so take take note, or let's emphasize on the difference between this larger population into our sample size. Okay, so the work of Mrs. Buson, if she's going to get this total number of 6,000 students, comparing to 1,000, just 1,770 students, so the bulk of work of Mrs. Buson will reduce. By using what? By using probability sampling and by using stratified random technique. Okay, now based on this example, take note that there are times that random sampling is impractical to use for a particular study. In such case, we are obliged to use the non-random sampling. Okay, so this is the second type of sampling technique. Okay, let me emphasize that our first technique is what we call random or probability sampling. Next one, number 2, is what we call the non-random sampling. Okay, what are those non-random sampling? Non-random, or what we call non-probability sampling, is a sampling technique where elements of a population are drawn based on the judgment of the researcher. Okay, so let's emphasize this one, okay, guys? So non-random probability or non-probability sampling is based on what? Based on the judgment of the researcher. So meaning it is based on what? On how the researcher will collect the data from her or his respondents. Okay, so next one is number 2 is what we call convenience sampling. So what is convenience sampling? You are asked by your teacher to conduct a study of how 6-year-old brother or sister or any 6-year-old child in your neighborhood. But there is a problem, okay? To have an ample time in observing and interviewing your respondents, here you are utilizing the convenience sampling. So meaning, so your respondents are the 6-year-old brother or sisters or just the 6-year-old child. Okay, and that is for the convenience sampling. Meaning, if I have this neighbor, a 6-year-old child, meaning she is one of the what? One of the respondents. So if I am from Tarlac, definitely I'm not going to Aurora to get this 6-year-old child, a participant or respondents to my study. So meaning this is one of what? One of the convenience sampling. Okay, so number 3 is what we call number 2 is what we call the quota sampling. What is quota sampling? Example, you are to investigate the relationship of students' performance in mathematics and their attitude towards the subject. However, you are only given limited time to do the study. So may you only consider 50 out of 500 students in your school. So this method is what they call quota, using a small samples. Yes, you have a samples, but by using the quota sampling, based on that sample, you're going to you're going to draw another sample on the sample size from the larger population. Okay. However, you may improve your sampling by using any random sampling technique to determine or in determining the respondents. Okay, so that is what they call quota sampling. So out of samples, you're going to draw another samples. Okay, so that is quota sampling. But again, take note, because you only given limited time to do the study. Okay, for the quota sampling. Next one. Note, there are times that sample in a study requires the whole population. Yes, definitely. There are studies that requires the total or the total enumeration of the population, or it requires the total or the whole population itself. Okay, what are those kinds of sampling? So again, this is another type of non-probability sampling. What are those? Number 1 is what we call census, or what we call complete enumeration. So what is census? Again, you are very much familiar with census, right? So it is a method of data collection from the entire population. Census, meaning no one will left behind from the from the total number of respondents. So if I have 6,000 respondents on the Pampanga State Agricultural University students, so those are my respondents. I'm not going to get samples from the larger population simply because it is census, okay, or a complete enumeration. Okay, next one. How about the number two? Or sorry, example is what? So for our example, to know if the brakes for cars produced by a car manufacturing company are of good quality, the company implements a strict rule for testing all of the brakes. Definitely. Okay, so if we're going to test the brakes of any car before before concluding that it is a good quality car, definitely we're going to implement what? A strict rule for testing all of the brakes. Okay, so that is what we call total enumeration. Continuing, I think this number 4, if I'm not mistaken. So observation or experiment. So what is this? Observation is applied when data can be collected without any response from people. Huh? How is that? How is that? Okay, so again, let me read again. Observation is applied when data can be collected without any response from the people. So you're just observing something, you're just observing the scenario, you're just seeing the scenario, or you're just hearing something. That is what we call observation. In meaning, you are not going to interact with those people from your population or from your sample. That is what we call observation. Now, how about the experimental method? For the experimental method, it is used to find the cause and effect relationship. And I think this is very much familiar with the science majors, okay, for the experimental method. Next one is what we call survey method. So what is survey method? Survey is used when data can only be obtained through responses from people in a sample. So this can obtain through questionnaires, which may be distributed hand by hand, face to face, or through phone interviews. I know you are very much familiar with surveys because you have already your practical research one, and that is qualitative research or quantitative research. Okay, continuing. Example is a survey to investigate the attitude of the students in studying mathematics. Okay, that is one of the title of a survey method. Now, after finding or after gathering your data, after identifying respondents, okay, so let's now move on data organization. So what is this data organization? It is a process organizing collected factual material commonly accepted in the scientific community as necessary to validate research findings. Okay, let me read the second definition. Research data is a data that is collected, observed, or created for purposes of analysis to produce original research results. So that is what we call the research data, meaning they are producing original research results, okay, from Boston University libraries. Now, why is data important in research? Any idea? Why is data important in research? So let me read. So data are intended to represent facts, or without proper preservation of the context of conclusion and interpretation may become meaningless. Again, the collection of data and its analysis assist researchers with discovering answers to their research questions and hypotheses. So in some cases, it even predicts future outcomes. Definitely. That is why the data in research are important. Yes, it is very much important if we're dealing on data on research. Okay, continuing. So ways of organizing your data in research. Yes, they are different kinds on or different ways on how will you going to organize your data in research. But for now, I'm going to give you at least three types in organizing data in research. Number one is the very commonly known way is what we call frequency distribution table. Number two is what we call the stem and leaf diagram. Number three is what we call charts. Okay, so let's discuss this individually. So what is frequency distribution table? Okay, so a frequency distribution table, example, the following data represents the scores of 10 students. This one. So the scores of these 10 students are 8, 6, 4, 5, 8, 8, 9, 10, 10, and 6. So our task is what? Our task is construct a table with 3 columns that the first column show what is being arranged in ascending order. So that is the scores, this one. So we're going to arrange the scores ascendingly. And then after which we're going to tally the number of frequencies. So we're going to count how many 4 are there in these 10 students. It's just 1. So that is frequency is 1. How many 5 are there? How many 5 scores? It's just only 1 again. How about 6? It's 1 and 2 and etc. We don't have 7 scores here. So this is what we call frequency distribution table. Meaning, from the word frequency, it contains frequency of the scores in a table. Yes, that is just frequency distribution table. Continuing. So a frequency distribution table in statistics, okay, it is a list of table or graph that displays the frequency of various outcomes in a sample. Okay, so each entry in the table contains the frequency or count of the occurrences of values within particular group or interval. Okay, but on my example, I still don't have the interval. Okay, simply because that is just what I call ungrouped data. Okay, so continuing. So categorical data, or what I will use the word that I say before, that is ungrouped data, determine the order to the list of the categories, then total the number of occurrences of each category. Okay, so example is this one, and this is what I call categorical or ungrouped data. Sir, but how about group data? Okay, so group data, it refers to data being organized into groups known as classes. Okay, so meaning if we have this group data in a frequency distribution table, definitely we have classes and we have intervals. Okay, so that's the difference between the categorical or ungrouped data to the group data. Categorical or ungrouped data, it does not have or it does not contain any classes or interval, unlike on our group data. So what is classes and interval? Okay, so on your scratch paper, kindly copy the following data that represents the ages of 20 respondents. So this is the ages of our 20 respondents. Kindly copy on your scratch paper. I'm going to give you, I think it's 1 minute to copy these numbers. Okay, so let me dictate 21, 26, 18, 45, 32, 41, 42, 22, 28, 26, 33, 20, 26, 44, 46, 21, 24, 39, and 30. Okay, so let's count this number of ages. So it should be 20 respondents. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we have 20 respondents all in all. Okay, so I think you're done copying with our data. Okay, so after copying the data, let's identify this. Okay, so how to identify this? Simply, it's just what? Number one, determine the highest and the lowest value. Okay, determine the highest and the lowest value of what? Of the data of our 20 respondents. So based on our data before, wait, let's go back to our previous slide, and I think my laptop is hanging. Okay, so this is our data. Again, what is our lowest number? So our lowest number here, I think it is 20, and the highest number is 45. No, it's 46. Okay, so 20 and 46 is our highest and lowest data. But I have here 18. Let me see again. Yes, we have 18 here. So our lowest data is 18 and our highest data is 46. So if we're going to divide this, if we're going to subtract this one, it is equal to 28. And this 28 is what we call a range. Okay, take note on the word range. Okay, so number one, we're going to get range. And our range is what? Highest value subtracted to lowest value, and that is 28. For our step number two is we're going to decide how many number of classes You want to have, example, 5 classes, but in your calculator, okay, kindly open your calculator. Okay, so use this equation. Square root of what? Square root of 20. It's because our observation or our total number of respondents is equal to 20. So what is the square root of 20? Okay, so again, what is the square root of 20? So for the square root of 20, it is equal to 4.47. And we're going to round it up. So therefore, that is 5 classes. Okay, again, take note of the word round up. So even though it is less than 0.5, we're going to round up your classes. Okay, for our number 2. Again, let me repeat. Based on this one, square root of 20, and that is 4.47. Round up, that is equal to 5 classes. Okay, next one is how to compute the class width or class interval. So what is this? Class width or class interval? I'm going to show you later, okay? So I is equal to class interval. So to get this, just divide the range, divide, and the classes, number of classes. So what is the range? 28. The number of classes is 5. So therefore, 28 divided by 5 is equal to what? Is equal to 5.6, and again, round up, that is 6. So meaning our class interval is 6 and our classes is 5. Our range is equal to 28. Okay, now continuing. Okay, so let's continue on our step number 4. Lower class limits, that is what they call the smallest number of each class, and the upper class limit is it is the largest number of each class. Okay, for the lower class limit, that is 18, 24, 30, 36, and 42. For the upper class limit, it is 23, 29, 35, 41, and 47. But sir, how will you get this one? I'm going to show you in the table later, okay? So number 5, class boundaries, the number of that separates the classes from one another by subtracting 0.5 to the lower limit and adding 0.5 to the upper limit of the of each class. Okay, so to further understand this number 4 and number 5 step, I'm going to show you the table itself. So we have the tally already. Now, again, what is our lowest number? 18. So therefore, if I have 18 here as our lowest number or lowest data, definitely I'm going to add what? 5 to get our class interval equal to 6. Why? Simply because if I have 18 plus 5, definitely that is 23. So what is the interval of 18 and 23? It is equal to 6, simply because 18 and 23 are included. So let's count. It is 18, 19, 20, 21, 22, and 23. Now, how many numbers are there in 18 to 23? It is 6. And what is that 6, sir? That 6 is what we call the class interval. Gets? Okay. Now, sir, how about the class? How about the number of classes? The number of classes is 1, 2, 3, 4, 5. Meaning, your number of classes must be equal to 5, and your class width or class interval is equal to 6. Okay. So the smallest number is 18. So definitely, plus 5, that is 23. So that is 6 as our interval or I. Now, to get the second layer of our frequency distribution table, you need to add 1 into this 23. So that is 23 plus 1, and that is 24. Again, what should I do to get the upper limit? To get the upper limit, plus, yes, very good, plus 5. So that is 24 plus 5, that is 29. Plus 1, that is 30. Plus 5, that is 35. Plus 1, 36. Plus 5, 41. Plus 1 is 42. Plus 5 is 47. But the question is, sir, isn't it our highest number is just 46? Why do we need to have 47? Simply because our class interval is equal to 6. You need to fulfill the number 6 class interval here, even though we don't have any 47 respondent. Okay, so by tallying, that is 5, 6, 3, 2, 4, and that is equal to 20. Okay, next one. How about the stem and leaf diagram? For the stem and leaf diagram, example, a method used to organize statistical data that help us to see values according to their size, so we can order them accordingly. In stem and leaf diagram, each data value is split into stem and a leaf. That's why it is called stem and leaf diagram. Okay, how's that? Example, I have your numbers, series of numbers, 97, 92, 77, 82, 96, 75, etc. What is this? Construct a stem and leaf diagram that will represent the data below for the science or the science test scores for the third grading period out of 100%. So the table is like this. But how come? Okay, for the stem and leaf, definitely we have this column stem and we have leaves. Okay, for the stem is we're pertaining on the tens digit. So what is tens digit? Tens digits is like this 21. The tens digit of 21 is 2. That's why you need to put 2 here. And the leaves or the leaf is equal to 1 simply because this is what we call the ones digit. Same as true with 34, okay? 34, 3 is the stem, so therefore that is 30, and leaves is 4, and that is 34. Where is 34 here and this one? Same as true with 55, so this is 55. So the stem is 50, and the leaf is 5. Now for the 68, we have 268 here. Number 1 and number 2, yes, this one, number 2. So for the stem and leaf, we have 268. So therefore, the stem is 60 and the leaves are 8 and 8. You need to write the 8, the 2 8s here for the leaves of 60. Okay, next, same as true with this one, the 75, the 79, and the 77. Okay, so 79, 75, and 77. Same as true with 80, 80, 81, 82, 84, 87, 87, and 88. Same as with 92, 96, 96, 97, and 97. Again, the stem is what? The stem is the tens digit and the leaves are the ones digit. That is what we call stem and leaf diagram. Okay, now let's proceed on the third one. That is what we call graph or chart. So what is this? If we have this condensed large amounts of information into easy to understand formats that clearly and effectively communicate important points. Okay, so that is charts and graphs. So the most commonly type of charts or graphs is bar chart, pie chart, line chart, and histogram. Okay, so let's dig in or let's discuss everything about this. Number 1, bar chart is, it is a composed of discrete bars that represents different categories of data. So the length or height of the bar is equal to the quantity within the category of data. Okay, so a bar chart is best used to compare values across categories. Take note, values across categories. Like this. Okay, so it is what they call grades in science for the first to fourth quarter. Meaning, based on this one, on the fourth quarter, they have this 93. Okay, so this is what they call bar chart. Next, how about a pie chart? Yes, you are very much familiar with pie chart, like pizza. Okay, so pie chart is what? It is a circular chart used to compare parts of the whole. It is divided into sectors that are equal in size to the quantity represented, like this. Okay, so example is the monthly household expenses of rich family. So based on this one, the 40% is from the grocery. The 10% is from what? From the internet. The 30% is from others, and lastly for the 20% is from electricity. So that is what they call pie chart. Next, so how about the line chart? A line chart displays the relationship between two types of information, such as the number of school personnel trained by year. like this. Okay, so the daily temperature in Luna, La Union. So Monday, it's 29, Tuesday is 33, Wednesday is 31, Thursday is 36, and Friday is 34. Something like that. So this is what I call line chart. Okay, and let's have the last one. And this one is what we call histogram. Histogram has connected bars that display the frequency or proportion of cases that fall within defined intervals or columns. Take note, histogram is like the bar chart. What is their difference? Yes, definitely. The only difference is these bars are compressed. They don't have categories, but it has classes like this. Okay, so that is what I call histogram. Okay, so I think that is all about on how will you present your data or your research data in a table manner, in a chart manner, and in a frequency distribution table. I hope you've learned about something about our discussion for today. And again, thank you for listening.